Yeah, good morning, good afternoon, good evening. Welcome to the second part of this training. We are fortunate to have yet someone great speak to us again, and I'm going to just share my screen now to uh, talk a bit about him. Then I will bring him up. He's already at the studio with me. So his name is Basi Nnemeka Ugbodo. He's actually is a academic faculty member at the College of Medical Sciences and Bruce Ali University, Eboma in Edo State. So he will be speaking to us on the application of statistical methods in research. So briefly about him too, is one person that has done so much in research, and he has a whole lot of laurel to his name, a lot of publication, and equally a whole lot of capacity building for undergraduate and even graduate students. So he's also a graduate student too at the same university. So we are pleased to have you join us. So the floor is yours, Mr. Bassi. The floor is
Good
yours.
evening.
So
All right, I
yeah,
can hear you. Good evening, everyone. I hope you can hear me clearly.
yeah, we can hear you very well.
Um, the facilitator has already said my names are Basil Nemeka Obodo. I'm actually a research consultant in some firms, and I also engage in quality research, and I've been following the training right from yesterday. And without further ado, I would like to quickly share my screen, and from there we can kick off on this
Please let it
wonderful.
be on the presentation mode, please. Thank you.
Yeah, that's exactly what I'm working on.
Okay.
All right. So I'm going to be taking us through some basic statistics and application in research. Right from yesterday, we all have been looking into what a quality research should all be about. And secondly, today we also looked at how to identify research gaps and be able to draw up some research questions from those gaps that we've been able to identify. So going by this, I will say that having been able to know that there is need for us to have a quality research, and there is need for us not just to go into a blind research, there is need for us to have a niche. And that niche that we are creating is what we call the gap that you've identified. And having identified this gap, we want to create some research questions. And having created the research questions, the next thing is how do we apply this research knowledge to be able to achieve and answer those research questions. And that is what we're going to be looking at throughout the course of this study. Here we have basic statistics and application in research. And before we continue, I would like us to look at this outline. We'll have a definition of what some of the basic statistical concepts. We'll look at descriptive and inferential statistics, basic statistical analysis, research design, parametric and non-parametric tests, choosing the right statistics. Then how does this statistics apply in research? What is the role of statistics in research? Now, understanding statistics is essential in research across various disciplines. I am quite sure that there is nobody, whether undergraduate or at the graduate level or even at the PhD level, who will undergo that kind of training without an adequate or quality research. Whether you are in medicine, whether in agriculture, any field at all, you must engage in research, in statistics, for you to be able to come up with a quality research. Now, when we look at statistics holistically, we'll discover that statistics basically is deals with methods for collection, analyzing, interpreting, and drawing conclusions from the information that we've gotten already. So that is the general introduction of what statistics is all about. It helps us to identify the methods. How are we going to collect data that will be commensurate or that will be equal or that will be in line with the research questions? How do we analyze these data that we've collected? After analyzing, there comes interpretation. How do we interpret? And how do we make conclusions out of what we just interpreted? Now, statistical methods can be used to find answers to questions like what kind and how much data do I need to be collected? How should I organize and summarize the data? How can I analyze the data and draw conclusions from it? So these are the basic statistical concepts that should always ring in our minds in each time we are looking at our research questions. In other words, statistics gives us a broad view of the design of the research, the description of the research, and making inferences from the description and the conclusions. Now, in the line of this presentation, we'll look at research design, descriptive statistics, and some inferential statistics. Now, like I earlier said, statistics is a collection of methods employed for collecting, displaying, analyzing, and drawing conclusions from the data. Now, in statistics and in research, we will definitely come across some basic concepts like parameters, descriptive statistics, inferential statistics. So when we talk about parameter, we are discussing about the number that summarizes some aspects of the population as a whole. For example, in the medical research, you can have such parameters like they'll say you're working on liver function parameter, you're working on other perspective parameters. So when we talk about parameter, we're talking about the number that summarizes some aspects of the population that we are looking into. Now, a statistic is a number computed from the sample data. After you must have done your sample collection and analyzing, the result that will help you to do the actual interpretation of the result is what we regard to as the statistics. Now, descriptive statistics is the branch of statistics that involves organizing, displaying, and describing the data. Now, when we discuss about descriptive statistics, just like we'll see later, we have some of the elements or concepts that helps us to organize the data in a holistic way that will make us interpret whatever we've gotten from our research in a holistic manner. Then, but inferential statistics will help you to draw out conclusions from the whole broad view of the research. A population is another concept that we should be conversant with. Is the entire pool from which a statistical sample is drawn. Let's take for example you're working on a student, you're working on a particular parameter on students. The student becomes the population, but from that population you can decide to draw out some other sample populations that you can also use to reflect on the inferences on other population. Now we also have measurement, which is described as the number or attribute computed for each member of a population. The measurement of sample elements are collectively called the sample data. As we go on, we'll be able to identify some of these basic elements in the course of the study. Now we have qualitative data and quantitative data in the course of the research. Now, quantitative data deals with measurements for which there is no numerical scale. When we talk about qualitative, we are either talking about is this present or absence? Is this a male or a female? They are all qualitative. So when you have an attribute or a measurement in a statistical concept where there is no wholesome number or numerical scale attached to such concepts, you can call such kind of data qualitative data. Now, while quantitative data are numerical measurements where you assign scales to them, you can say height, You can describe the height. You can describe the height of an individual. You can describe the weight of an individual. You can attribute some numerical strength and numerical quantities to some elements, even in the research. So data where that have natural scales or you can quantify are what we actually call quantitative data. Now, in the course of research, there is a concept that gets people most confused, and that concept is the concept of variables. We have to look at what variables is all about and see whether we can have a distinction or discuss the differences in the variables. Now, in statistics, when you mention of any variable, you we are talking about what are the characteristics in that particular population that varies from one individual to another, or that varies from one population to the another. Now, we can describe height as a variable, we can describe weight as a variable. So variables are what differentiates population in a statistical concept. Now, we can have quantitative or numerical variables, like I mentioned earlier in the previous slide, that will have quantitative data, those data that come with numerical strength, or you can assign some numerical numbers or numerical scales to them. Example, we have height, we have weight, we have number of siblings or number of students in a class, or number of smokers you have in a particular community. So in as much as there is a numerical value attached to a variable, that variable becomes a quantitative variable. Going further, we have qualitative on what we regard to as the non-numerical variables. These are variables that there are no quantities. They are not quantities. They are actual. They don't have any numerical scales or variable numerical strength attached to them. So when we talk about sex or gender, it can either be male or female. When we talk about marital status, it can either be married or not, single or divorced, or the case may be. So those are the examples of qualitative numerical variables. Now, under these qualitative numerical variables, you also have other subdivisions like the ordinal qualitative variables, the nominal, and the binary. When you discuss the ordinal variables, we are looking at variables that are in order, variables that are ranked. Now, for some education students who engage in research, they use basically questionnaires to for their field work and to gather research data for their analysis. Now, ordinal variables in that questionnaire, you could have something like rankings like strongly agree, strongly disagree. So most of these variables or this variable actually is ranked. So, so in that particular questionnaire, you discover that strongly agree ranks higher than agree, and agree ranks higher than disagree, and disagree ranks higher than strongly disagree. Those are what we when you look at when you have such kind of variables that are ranked, you call them ordinal qualitative variables. Nominal variables are variables that represent group names. Maybe you can say male or female, you can say yes or no, absent or present. So when you have such kind of data that describes the absence or presence of um, of a particular parameter of interest, or probably you have male or female, those kind of variables are what we refer to as the nominal variables. Now we have binary variables that also describes the outcome in two positive ways, either yes or no, or win or lose, or the case may be. Now, very important for us to look at what we describe as discrete variables and continuous variables. Discrete variables are variables that you get as a result of maybe physical counting. For example, you can come you in a community, you can say the number of children in a community that are predisposed to malaria is 100 or is 50. So when you have such kind of description, what you're discussing at that point is what we call discrete variables. Now, in a particular community or in a particular state, the road safety corps might just decide to come up with the number of accidents that occur in a particular region. So any that such kind of variables are what we refer to as discrete variables. Now, we also have continuous variables. Continuous variables are numerical variables. For example, you can say the length of a table or the length of a species is 2 cm, the weight of this individual is 2 kg. So those kind of variables that have numbers, or that have numbers quantitatively assigned to them, that is what we refer to as continuous variables. So in the course of this study, if you have any question, maybe at the end of this study, we'll be able to tackle them. Now, we discussed population and sample. This is just an example of what population and sample is all about. The Looking at the left-hand side from my screen, you will discover that you have a population described in a rectangular format. Now, from this population, when you want to sample, if you bring out samples from this population and analyze that sample in a so that at the end of the day you can use whatever you have sampled to make inference on the whole population. So that is what gives us a distinction of what population and sampling is all about. For example, you might want to conduct a study in Nigeria on the prevalence of malaria in Nigeria, but we actually know that it's practically impossible for us to sample every Nigeria. We're almost 190 million citizens in this country. So it might just be nearly impossible for you as a statistician or a researcher to sample all the what do we call it, all the citizens in this country. So in this regard, what we do is that you can take a sample that can probably represent each state, and when you sample such kind of data, you can now say, okay, in Edo State, I'll sample 3 different communities. In Lagos, I'll sample 4. So, but in subsequent trainings, I don't know who will be taking us on that, on sampling techniques, on how you can get your sample size and your sampling techniques. So now I gave us an example of what a statistical problem is all about, of which I believe must have been covered in identifying research gaps. Now, I've given us a little intro on what descriptive and inferential statistics is all about. So, like I said, descriptive statistics helps you to organize and summarize your information, while inferential statistics makes you to draw out conclusion from the data that you've analyzed. But in descriptive statistics, you also discover that it has to do with such measures like maybe the mean, standard deviation, percentile, decile, and at the end of the day, you can now descriptively present this data in graphs, charts, or tables. That's what you see most times in research, in the result aspect of your research. You will definitely represent them on a graph, a chart, or a table. So such kind of representation is what we refer to as descriptives. But when we now start making inferences to hypotheses and other statistical theories to make sure that we draw out a conclusion from what we've analyzed, that is what we refer to as the inferential statistics. Now, we'll be looking at basic statistical analysis. There are procedures for us to that will guide us through when we are doing some basic statistical analysis. And one of them is you begin by formulating your research problem. The first speaker that actually gave us more information on this, how to formulate a research problem. Then you define your population and your sample. That is where sampling techniques and your population of study comes into play. Then when you must have defined your sample population and determine the number of samples, the number of sampling or samples you'll be using for the study, you have to collect the data, you analyze the data descriptively, and use appropriate statistical method to solve the research problem. Then at the end of the day, you will report your results. Please, I want us to note that even if we don't go home with anything today, I want us to know that it's not just important, or it's not just only important for us to know the right population or the right sampling that we use or the right data we collect. No, it's possible you can collect the right information, but at the end of the day, you will use a wrong statistical method to analyze your data. And when you use a wrong statistical method, your result definitely will be affected. And in such case, cases, your research work will lack quality, focus, and reliability. Now, we have what we call measures of central tendencies, which is part of the descriptive statistics that we discussed earlier. Here we have, I wouldn't want us to waste much time on this. I just brought it out so that we just have an idea of what measures of central tendency is all about. They include the mode, the median, and the mean. Of course, basic statistics must have given us information on what each and every one of these is. We also have measures of variation. We have the range, we have the standard deviation, and we have the interquartile range. If time will permit us, I will still want to come back and throw more light on this. But both the measures of central tendency, the mode, the median, the mean, the range, the standard deviation, and the interquartile ranges, they are all part of the descriptive statistics. So when you are doing a research and you choose the appropriate statistics that is suitable for the type of research you're doing, then you can now decide which of these descriptives will be suitable for you. Now, very important for us to know is that it's not just it's not just it's as important as also knowing the research design that we'll be using for the work. There are a whole number of research design, but I think I tried as much as possible to concise it and give us the basic research designs that mostly you find routinely used or commonly used in research. Research design cannot be considered as can be considered as the structure of the research. Yes, research design is actually one of the most important aspects of research. So it is the focal point that holds all of the elements in research projects together. It is a plan of the proposed research work. So okay, so research design helps you to have a structure. It helps you to have a mental picture of how your research is going to be like. It helps you to determine the number of samples. It helps you to know your population. It helps you to know the right type of statistic element to use. It helps you to define your concepts. That is what research design is all about. So any research that is devoid of a quality research design would definitely be marred with a lot of flaws and inconsistencies during the conclusion and the analysis stage. So it is important to know that for you to conduct or to have a quality research, it is very, very pertinent that you first of all have a good structure of your research, which has to do with the research design. Now, we have types of research design. We have descriptive research design. Now, this kind of study or this kind of research design helps the researcher to describe a situation or a case under their research. Now, most times in the medical sector, the hospital setting, now the clinicians they do a whole lot of case studies. So most case studies they are actually regarded as descriptive research design. Most case studies. So this allows the researcher to provide an insight into why and how of a research. So why Having identified a particular ailment or having identified a particular disease condition which is prevalent or which is rare or which occurs once in a while, and they want to present it in a research format, the design they will use is what we call the descriptive research design. If they use experimental research design or any other type of design, it will not fit in properly into the hypothesis or the research structure the researcher is always having in mind. Now, we also have the experimental research design. This has to do with experiment. You want to find out the cause. For example, what is the cause of what the prevalence of a particular disease in a community? What is the cause? So you need to go for sampling. You need to go to field work. You need to carry out some experimental studies. So such kind of research where you have um, a situation whereby you want to find a relationship between a cause and effect of a situation. So in that kind of research, that's what we refer to as experimental research design. Now, we have correlational research design, diagnostic research design, and explanatory research design. Correlational research design deals with relationships. You want to get a relationship that occurs between a parameter or between variables, both whether independent or non independent or dependent variables. For example, you want to look at the the relationship between nutrition and malaria. Are you trying to say that the as an individual is becoming malnourished, malaria increases, or as the individual feeds very well and is living a healthy and a healthy life, how does it relate to malaria? Is it increasing the malaria or is it decreasing the malaria? So such kind of research design that have to look at the relationship between variables. That is what we look at correlational research design. Diagnostic research design is for diagnosis. If you have any kind of a research that has to do with diagnostic approaches. Now, at a point, a researcher could want to, draw up a write up on a particular topic, explaining, after having explored other type of other having explored other literature review, the researcher wants to kind of give a concise or a brief summary of what he or she must have researched on. So the person comes and uses the explanatory research design to give a vivid and a concise, summary of what he or she must have researched on. Before I forget, there is also another aspect of research design that most times we are not used to such in this part of the world, which is the meta-analysis. So, but maybe with time, we'll be able to look at meta-analysis. But meta-analysis is simply a type of research where you do a review of what other persons have done in a particular work, and you use some basic statistical method to look at the variances, the discrepancies, or the similarities between these various research. And from what results of these variances or discrepancies or similarities, you will come up with a conclusion. That's also another type of research design. Now, for you to have a good research design, your research design should at least try to answer some of these research questions, some of these questions, sorry. For example, this your research design must give us an explanation or give you, the researchers, an explanation of what the study is all about, what type of data is required, what is the purpose of the study, what are the sources of data needed, what should be the place or area of study, what time is required for this study, what type of sampling do you need, what type of data collection will be appropriate for your kind of study. Now, if you're doing an experimental research design, For example, for those of us in the medical sector, you know that definitely in a disease condition, you must go out to the field to collect the samples. And when you collect the samples, you now start begin to ask yourself questions. What are the parameters? And after analyzing the parameters, what are the other things that I am supposed, what are the appropriate statistical methods I'm supposed to use to get the desired result? Then how will the data be analyzed? Just like I pointed out, what should be the approximate expenditure? This takes us to what we call pilot study. Pilot study. What should be the specific nature of the study? Pilot study is a kind of mini study. Let me just call it market survey. Probably you want to carry out a research, you have to do a small pilot survey, probably look at the cost of your reagents, probably look at the how many questionnaires, the type of, you can even go to the community where you're working and look at whether there's the population you want to sample, they are even readily available in the community. Because I've mentored somebody who engaged in a research and didn't do his pilot study very well, and at the end of the day discovered that when he got to the field, the number of samples he was anticipating to get for the research, he was not able to get it, and that led him to, restructuring his research design, his research hypotheses and research questions, and trying to come up with what is obtainable, what would be obtainable for him in that particular community. So it's possible to know. It's important for us to know that pilot study is an essential aspect of research. Now, phases in research design. First of all, which is very, very important, we must specify the problem, we must identify the gap. Then you now look at the type of research design you will use, look at how you will collect your samples, how these samples will be analyzed, and in what format are you supposed to present the research. There are some professors, most times I will tell you, no, 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 no. This kind of research, you're supposed to represent it with chi-square. Others will say you represent it with a bar chart. Others will say represent it with a graph. Others will say represent it with a table. Depending on the type of research you're doing, will give you a clue on how the proper way of reporting your results. Now, what is the nature of a good research design? First of all, a good research design must be flexible, must be appropriate, efficient, and economical. Okay, but very important, you should design your research in a way that errors and biases will be, at least to an extent, minimized. Okay, then when you must have collected your data, errors and biases must have been minimized, and you analyze your data and you get a good result. I think that will give you a clue that you are also getting closer to having a good research structure. Also, a good research should be theory grounded. You cannot venture into a research without doing a proper literature review on the topic. If, for example, you're working on um, examination, the causes of examination malpractices in Nigeria, you should be able to go deep into your study, understand the theories and the concepts behind malpractices before you can venture into identifying your gaps and creating research questions and describing how you answer them. A good research design must be feasible. Feasible. Okay, now a research design has have four major characteristics. Number one is it must be neutral. Okay, your research should be as neutral as possible, and in that case, we should be able to make sure that whatever we are doing in terms of sample collection, in terms of research questions, should be free from bias or errors, as the case may be. Reliability, validity, and generalization. When you carry out a research in Lagos, for example, on a particular topic, if another researcher should go to Lagos to carry out that same research, the person should be at least get something very close to what you've gotten, and that is a good a good characteristics of having a good research design, okay, is should be reproducible. If I do a research work and I'm having and I'm saying that the prevalence of malaria in Edo State is 2.8%, another person should get something close to that because we are using the same population, the same community, and the same sampling method. Now we have the parametric and the non-parametric test. Now the in statistics, actually, statistics is divided into two. If I may use that word, you have the parametric tests and the non-parametric tests, and there are conditions. Now, this parametric and non-parametric test gives us a clue of the type of research the type of statistics to use to analyze a given data or the data you have for your research. So for you to be able to know the right choice of statistics to use, you should also be able to understand what parametric tests are and what non-parametric tests are. Now, in statistics generally, there are a whole lot of assumptions that must be met before you go into analyzing your data. So parametric tests, they deal majorly on assumptions. So your data collected from your research field work must meet all the assumptions before you can say that I am using a parametric test to carry out my research analysis. So data or parametric tests are those tests that make assumptions about parameters of a population. So as we go further, we'll look at some of these if time basic assumptions. So they are very strict. Parametric tests, they are very strict on these assumptions. And when these assumptions are not being met, the next point of call is to use the non-parametric test. So in other words, if I want to draw a discrepancy between the parametric and the non-parametric, I will say that parametric tests, they work basically on assumptions, and all the assumptions must be met before you use the parametric test. But non-parametric tests are very feasible and flexible. I need to say that they do not necessarily obey all the statistical assumptions. I believe when we have training on them, some of these statistical packages, these assumptions, most of them will be mentioned. Now, example of parametric test, we have the paired t-test, we have the unpaired t-test, or what we refer to as the independent t-test. We have the Pearson correlation, we have one-way analysis of variance. Now, remember that for paired t-test, the non-parametric equivalent of paired t-test is the what we call the Wilkinson rank sum test. Now, for unpaired t-test or independent t-test, the non-parametric approach is Mann-Whitney U-test. Then, Pearson correlation, we have the Spearman correlation as the non-parametric approach. One-way analysis of variance, which is what we commonly call the ANOVA, uses the Kruker-Wallis test as the non-parametric approach. So what this does is that if you have a data, whether continuous data or discrete, any kind of data you have, and you want to carry out a paired test, a paired t-test, and if you've checked the assumptions, and the assumptions of paired t-test have not been met with the data you have, the next option you have is to use the non-parametric equivalent, which is more flexible and does not really tie a rope on much of these assumptions. They are not very strict on these assumptions. Now, here comes the one of the most important aspects of this course. How do we choose the right statistics? Okay, how do we choose the right statistics? Now, to determine which statistical test to use, you need to first of all know whether your data meets certain assumptions. I've already said that. Two, the types of variables you have. Remember, I mentioned you can have categorical variables, you can have discontinuous variables, or rather, you can have a continuous variables or categorical variables. You have to look at these two things first. Now, for statistical assumptions, there are or very many assumptions like independence of observations, homogeneity of variance, and normality of data. On the statistical package proper, these assumptions, they will be explained in details. But now, these assumptions are some of the assumptions that we must look at before we choose whether we are using parametric or non-parametric. So if your data meets all the assumptions of a parametric test, then you can go ahead and use parametric test statistical tools. But if your data do not meet some of these assumptions in a whole percentage of them, then there won't be need for you to use a parametric test. You should be using a non-parametric test. Note, choose the test that fits the type of predictors or outcome variables you have collected. You cannot collect a you cannot collect a categorical variable and you want to use t-test, or you want to use ANOVA to analyze a categorical variable. Categorical variables are variables that are categorized into two, probably male or female, yes or no, present or absent. When you have such kind of variable, your mind should be thinking towards other type of statistical tools like chi-square and the rest of them that will help you to have a good fit on your research. Now, how do we choose a good parametric test? And I mentioned some of these parametric tests. I mentioned regression. There is a comparison test and correlation test. So regression tests are tests that we can use to actually determine cause and effect of relationship between variables. Okay, now let's look at this table. Now, when you have a simple linear regression, which is a type of regression, now the conditions for using this type of statistical tool is that your variable must be continuous. Your two variable, both the dependent and the independent variable, they must be continuous. Now, when you look at logistic regression, at least your independent variable should be continuous, while the dependent variable should be maybe categorical or binary, as the case may be. So the relationship we are trying to create is that there is a need for us to understand that the type of data you have gives you a clue on the type of statistical tools to use. So for you to use a regression test, these conditions must be met. Now, let's look at the basic ones that we know. T-test, that looks at the differences among mean. They can be used to test the effect of a categorical variable on the mean value of some other characteristics. Example, you have the t-test, you have the ANOVA, you have the MANOVA, and the case may be. Now, this is a, a diagram. Now, for you to use a PET t-test, there are conditions. You should have a categorical variable, and you also have what? A quantitative variable. So if you're having two quantitative variables, you cannot use PET t-test to carry out most of these tests. Now, let's take for example the independent t-test. Your variables must be categorical, and your outcome variables, which is your dependent variable, must be quantitative. So these are slight differences that we are supposed to look at when we are making the right choice. Now, for a non-parametric test, which I said is not strict on most of these assumptions. I've already mentioned them earlier, that we have Spearman, we have chi-square, we have sine test Kruka-Wallis, and we have the list, the parametric equivalent at the end, the last column on the table. So when you look at these statistical methods, you discover that it's very important for you as a researcher to know the type of data you have. So that type of data you will have will definitely give you a clue on the right choice of statistics to use. Now, application of statistics in research. Statistics play a vital role in researches. For example, Statistics can be used in data collection, analysis, interpretation, explanation, and presentation. Use of statistics will guide researchers for proper characterization, summarization, presentation, and interpretation of the results of the research. This is what statistics helps you to do. Okay. Now, it provides a platform for researchers, what to do, how to consider a sampling, how to look at your population, the techniques you will use, and at the end of the day, describing your data in the most suitable way. So that means in research, without statistics, there's no way you can present your results. In research, without statistics, there's no way you can there's no way you can do a proper analysis and get the results on what you have been looking for. Now, the role of statistics in scientific research, like I mentioned, it helps you to control sources of variation and detection of outliers. It helps you to visualize the data, analyze with statistical modes, interpret practical and statistical significant results, then finally make scientific sound decisions and communicate them. The person that took us on identifying research gaps said it is not enough for you to do a good research. It is also important that after doing a good research, you know, you must make that research to be known to other persons by communicating this your outcome to the outer world through publications in reputable journals. So that's what statistics. So if you don't have a good knowledge of your research, when the reviewers go through your work, they will be able to know if you've used the right type of statistics for the kind of data you have. And when you don't, you have to be you'll be queried and you'll be asked to make a whole lot of corrections before you get your papers published. So that is the reason why it is very important that as we the researchers we should know the right type of data to collect and the right type of statistics to use. Summary of applications of research of statistics in research. It helps informs methods on data collection. It helps us is used to support or negate a hypothesis. Okay, seeks out uncertainties, errors, and outliers in the data. Its interpretation, summarization, and communication of data sets. Okay, it helps us to have there are some data we have, and we need to design a model. That is what we talk when we discuss regression analysis. We will have regression models to have some predictions about outcomes and all that. That's what statistics does. And at this point, I will quickly want to stop here and see if I can entertain one or two questions, and then we'll wrap it up. Thank you very much.
Thank you so much for this wonderful, excellent, and in fact, um, this is one of the most very extensive presentation in the aspect of application of statistic in research. I must confess, it's total. It was well thought out, and sincerely is an awesome presentation. And a whole lot of our colleagues are already asking for if they can get if we can get the slide across to them. So I will seek your indulgence probably after this presentation. If we can look through, then send it across to them. We'll just convert it to a PDF and send to them. I must say that it's a very, very wonderful presentation. Keep it up. Yeah,
Thank you.
to be kindly, there's no actually much question here. Then I think one question that comes up was how do we use statistics to actually determine you, because the person mentioned that during your presentation you mentioned that statistics is equally important in sample size determination. So how do that come into effect?
Okay. Okay, yeah, you remember? Can I answer now?
Yeah, go on, go on, go on. That's actually the
Okay,
basic question. I think you've answered all other questions.
okay. Yeah, in statistics will help because when you actually want to carry out a proper research, you don't just want to go into the field and just take any kind of sample population sample. You do just do a random sampling and you come up with a sample and say this is my sample size. No, there is I for maybe in the final Mr. Leo, maybe in the final
Yeah, I'm with you.
yes, I
Presentation,
will
yeah.
have to, yes, in the final presentation or the one we send to across to them, we will have to include the formula for calculating the sample size.
Okay.
Yeah, there is a formula for calculating the sample size. But during your literature review, there is a problem most students encounter when looking at this sample size calculation. Now, you must dig deep and know the prevalence of what you are looking for, because that's the basic parameter that will give you issues when you are calculating for the sample size. So you have to dig deep into your literature review, get the prevalences of whatever prevalences or the outcome of previous researchers. Then from there, you will now use that prevalence to impute in that formula. There are a lot of formulas for calculating sample size statistically. So when you get the material, you'll be able to. I think I'll try and include the sample size calculation so that you will use that to do your calculation. But note that you have to know the outcome of the previous researchers in that particular area. Thank you.
Okay. Thank you so much. We really appreciate your coming to make this presentation. We must say that is one that was very thought out. Um, so since there is no much question, we want to appreciate you for joining in, for taking our time to make a good presentation and present to us. So we which is also one of us at Research Hub Nigeria. So we believe that in no distant time we should be able to bring him up again to speak more on some aspects. And he made mention of meta-analysis. There's a training that we are going to be bringing up soon, although I will discuss that with him. Although that is going to be majorly for those that are in the, I think it's going to be more useful to those that are looking out for graduates that want to go into graduate studies for masters and PhD, as the case may be. It's going to be coming up, although it's going to be like a 3 days training too, although that might not be free as the case may be. So we'll make the details known to us equally. So we want to thank Mr. Basi for coming to speak to us. We wish you well in your future endeavor, as you progress in your academic career and research career. Thank you so much.
Thank you, Mr. Leo.
Yeah. All right. See you.
All right, thank you.